just a quick review for this book, Livewired by David Eagleman. I'm going to give this book 4 stars. Very interesting. I really like the book. Some parts of it are a little speculative, but he's a great author. I really like his style of writing. Very clear. Really clear what he wants. He uses very good examples and metaphors. One of the best I've seen. He's really good. I've read his other book called Incognito, also very good about the brain. He's a neuroscientist by training. I really recommend this book, especially if you're interested with brain stuff, which I am. And this is really a good book. Again, good metaphors, good writing, short, straight to the point. Again, a little bit speculative. That's why it's not a 5. It was close to there. I've learned a lot, even though I am in the field. I still learned a lot. He's very good at packaging. You put things in make good connection between things. Put things in a good package, even though some things are known about, for example, neuroplasticity. But again, the packaging matters, and it's very clear. Let's see the notes. Humans have photosensors, blood pumps, and machinery to metabolize energy from all around. So that's a quote, and I really like the way of putting it. It's just like a machinery, and what we do is basically metabolize energy from all around us. That's how we understand the world. That's how we function. Unlike the textbook description of the brain as having specialized regions, the brain is more dynamic and similar to a living culture forming connection. So it's not each part is responsible for one particular thing. Rather, the brain is a very connected, or more like a living culture. There is connection between it. The brain is more like a globe where borders are subject to change. Neurons fight for resources and get specialized upon utilization. So the globe borders, we have borders, and they're subject to change. Same things with the brain. Regions can change functions, and he adds to that neurons fight for resources, and there is a fight for resources. Whatever is more get more specialized. Whatever we do more things, usually get more resources. After the war, Japan used its engineer to work on the bullet train. So that's another example of utilization and adaptation using the engineers that worked on war related projects to work on the bullet train. So repurposing. Unlike plastic, neuroplasticity keeps changing along the lifespan. So it has the name plastic in it, but neuroplasticity keeps changing over and over. Livewired represents how the brain functions as it reconfigures itself. So that's what Livewired is. It keeps changing, and it can readapt neuroplasticity. That's what it means, Livewired. More than that is that you can plug in things, which you're gonna see a little later. In a deprived environment, rats have smaller brains in comparison to those who live in a normal and richer environment. So it affects. So again, we see the plasticity of the brain, where if there is not enough stimuli, the brain doesn't grow. The body image in the brain can transform and change when things change. For example, if people lose one arm or get blind, deaf, or any of those, the body image in the brain changes in accordance. Neural connection is all about timing, where those who fire together wire together. So that's the idea of wire together, who fire together, wire together is because timing. It's all about the timing when one thing fire, and if other things do, they also wire together. The more real estate dedicated to a certain task, the better it would be done. So that's how blind people are better. They have better auditory system, for example, because there is more real estate dedicated to that certain particular task, and therefore it gets better. Brain remapping can happen swiftly and within days. It doesn't take too long. and they had some research to support this. According to one theory, dreams are visuals because that part of the brain fights for resources due to the lack of use that otherwise happens. So what happens when we go to sleep, the visual cortex, visual part of the brain, is not engaged. And according to the theory, that region fights for survival, and therefore our dreams have visuals. Different part of the brain of blind people is taken over by other senses. That's the repurposing part of the brain, but the recalibration, plasticity, where it's being taken over by other senses. The brain simply takes electrical signals and interpreting it. According to one theory, the brain can adapt to many different stimuli, more like a plug and play situation. That's the Livewire idea we introduced before, that you can plug and play things. That's the Livewired. The brain just use electrical signals, and we can plug in, quote unquote, different stimuli in order to get different information. Since all stimuli is essentially electrical pulses, the brain can adapt to different ways of seeing the world. Again, it's the same idea. So because it's all electrical stimuli, we can adapt to different way of seeing the world through other senses or through other things that we're not yet known to be connected. For example, he has some ideas about connecting other stimuli that are robotic in a way. The brain can use auditory signals to figure out the shape of the object. That's another way our brain can see the world. Plugging in new stimuli can be adaptive and used quite quickly. So this is again similar idea that we can adapt to new stimuli rather quickly. Instead of visual gauges, we can use sensory information to feel the data. Only irregular data would be picked up by our brain. So that's that plug and play thing. We don't, instead of visual gauges, we can connect sensory information in order to feel the data. We don't have to see the data, we can feel the data. I'm not sure how it works. That's the speculative part of the book. And the way it would work, though, the way it would function is that only regular data would be picked up by the brain, because other than that, we're just going to be overwhelming. According to one theory, the qualia, that is the properties of different sensory information, is structurally different and therefore cannot be interchangeable. So the qualia is the properties of something are different from stimuli to stimuli, and therefore they cannot always be interchangeable. Side note, the book is a little speculative. There is quite a few in the first, it depends, some parts have more, but there is some speculation about the plug and play thing. I'm not sure how it exactly would work yet. I think we're a little far from that. And he has quite a far-fetched ideas there. Little sci-fi ideas. Next. Motor babbling is similarly to language babbling, where input tries to match output. Motor babbling is kind of like trying moving. It's like a baby when they try to move. It's kind of a trial and error situation, similar to babbling, language babbling, when they produce a sound and they compare input or output to input. Motor babbling is being used either robotics, and there's a typo here, where the robot battles in order to figure out its own limits in physique. So that's how they teach robots to walk, by babbling. They just try things, and that's how they learn the limits. That's how babies do it. That's how language work. Same thing. Thoughts function similarly to motor babbling, where there is a trial and error. He brings the idea, entertains the idea that thoughts function similarly, where there is trial and error. There is babbling, and we try different thoughts. Some work more than others, and we just get rid of those that don't. We become the information we digest as the brain changes in accordance to what we do. So we literally becomes what information we have, because that our brain changes in accordance to that. There is a hormone responsible for more or less plasticity. They found a hormone that enables plasticity, but there's more than that to plasticity. Relevance appears to increase plasticity, how relevant the information is. Without engagement, there is no enough plasticity, which is why the current educational system fails, because there is no engagement. It's just throwing different facts, and it just doesn't work, because plasticity doesn't work as well, because there is no engagement. That's why study groups, or the Talmudic way of learning is more effective. Study groups is making it more engaging and relevant. That's the Talmudic way, which is like learning one by one and posing questions. It's also a very effective way of learning. However, randomly throwing facts on students is not effective whatsoever, because there is no engagement, there is no relevance, and there is no plasticity as a consequence. The motion illusion after watching a waterfall happens because calibration, as even after closing eyes, we still see motion. So what happens in motor illusion is we watch a waterfall, and we look away, things look like as it moves. And that happens because our brain calibrates to that. Thing is that it's not a matter of getting habituated to it, because even closing our eyes doesn't solve the problem. So it's literally calibration until the brain recalibrates itself to static form. The motion illusion is a consequence of the brain trying to adapt to regular input in order to detect changes. The brain just adapts to the changes, and the reason it does it in order to detect changes, because if everything moves, you get to know what does not move or what moves faster. So in order to that, you have to take into account things that are moving. What does not change disappears in the system. So that's the system tried to get rid of it, because if it doesn't change, it doesn't matter. The brain is trying to predict what is constant in order to avoid energy expenditures as neurons spike. So that's another reason why the brain is trying to recalibrate things, because it's trying to predict what is constant. And the reason it does that is in order to save energy, because if things move, there is neuron spike, and they take a lot of energy. Attention could be seen as recalibration. That's what we do. When we pay attention to something, it's recalibration to that specific task. Tolerance works in a similar way, where the brain predicts some amounts of the substance in its models. That's why tolerance happens. The brain is getting recalibrated to the new situation. It takes into account that particular substance, and therefore it's not as effective. Balance is a consequence of a competition. What happens in balance? It's the way to achieve balance is by competition, not by other means. Neurons are similar to drug dealers, where competition for real estate is constant, but equilibrium is nonetheless achievable. So it's a similar idea. How do you achieve balance? By competition. You have neurons that battle for survival, but they do reach some kind of equilibrium. Same thing with because they fight for real estate. Same thing with drug dealers. They reach equilibrium without deciding it in advance. It's kind of like a trial and error. Okay, you try here. Oh no, it doesn't work here. Try here. Try here. Eventually, you settle down. Not seeing good with one eye is solved by patching the other eye, which makes the former use more resources. So it's not by doing it the other way, which they tried different ways, but actually covering the good eye is making we call it the lazy eye, more active, which is how to fix the not good eye. According to the author, cancer could be a result of fierce competition where cancer cells survive. So because of a competition, cells that do survive, which is cancer cells, so it's a fierce competition where those cancer cells overcome other cells and they take more, they just survive more. What if neurons compete and try to outsmart other neurons just like the trees in the forest? So he entertains the idea that there is a fierce competition in the neurons. And just like trees in the forest, they try to overshadow other trees and they try to take all the sun for themselves. And same things maybe happens with neurons. They try to outsmart, they try to take resources from other neurons. Just like countries settle down into their own borders, neurons lose plasticity as we grow older, because when we grow older, we have less plasticity. And one of the reason is that it's just everything settles down more. Like a good metaphor he uses is the borders of the country. Plasticity narrows down to adaptability versus efficiency. So that's what there is a trade-off with plasticity, because in one hand it's good to have plasticity, but when you have too much plasticity you have no efficiency because it doesn't function as well because there is so many options. However, if you're too efficient, you don't have adaptability. So it all comes back to that trade-off. Some areas of the brain are more plastic than others. Motor functions are more plastic than auditory functions, for example. So it's not, plasticity is not across the spectrum. There is more parts that are more plastic than others, and the reason is, you can see here, genes function similarly where some parts are more subject to change. For example, skin pigmentation for different latitudes as vitamin D changes. So different parts are more plastic because there are more changes in them. For example, the example here with skin pigmentation, that is more plastic. And because people move from different latitudes, that requires different absorption of vitamin D. If you live in the equator, you don't have to be very pale in order to, because there is enough sun. But if you're living in dark areas of the globe, you do need to have a lighter skin in order to absorb more vitamin D. And same thing going back to this one. The auditory functions do not need to change, and they're not as plastic because there is no much auditory changes. However, motor functions do change because things change in our environment. Memory is not located in one area. Rather, it's distributed around the network. There is no one particular place or region that is responsible for memory. It's distributed. Learning takes place through strengthening of the synapses, but it's not the full picture. So it's one way of learning is being done is by the strengthening of the synapses, but there is more than that. Unused memories move to a deeper layer, which are less likely, or less accessible, but could be reused when stimuli is present. What happens if unused memories are moving lower or deeper in deeper layers, and they're not as accessible to us, but if there is a stimuli, then it's more accessible. A useful metaphor for memory is the way the desert remembers the wind. It reflects numerous changes in cascades. So how the desert remembers the wind by reflecting the changes. So that's how he says that memory is. It's a reflection of what happens. It's kind of a cascade of that reflects what you know or what happened. Last one. The next frontier is figuring out how to program machines to work adaptably with a missing wheel, for example. So that's one of the issues they had with a Mars rover. One of the wheels stopped working and they couldn't make it work. So adaptability matters, plasticity matters, but we're still not there yet for machinery. Our machinery is not plastic whatsoever, and going there and being more adaptable is the next frontier. So these are the notes. Again, some interesting parts. I definitely recommend the book, especially if you're interested in the brain. 4 out of 5. Thank you.